I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to analyze concavity of a function. We are going to relate concavity with tangents and rate of change. It is a very important concept and it helps you in many different areas. Beginning from grade 10, when you start learning about parabolas and polynomial graphs, the concept of tangent and concavity comes handy and it helps you to understand the topics better. So we'll analyze these three basic graphs and see how and see what is the relation between concavity, tangents and rate of change. Let's begin with the very first one. We have a parabola right here which opens up. Now if you see this kind of a graph, which is basically a parabola that opens up, in that case what is the concavity? Well, clearly here the concavity is concave up, right? So it is concave up when the parabola opens up. Now, if I draw a tangent line, where all can the tangent line fit in? Well, if I have a tangent line on the left side of the graph, as you can see, it is under the curve. Here also it is under the curve. Anywhere on the right side also, we see that the curve is above the tangent line, right? So you do notice that it is concave up, and secondly, we always see that the curve is above tangent. Perfect. Now, let us also understand the rate of change. Rate of change is slightly difficult and tricky. What do we notice here is that the slope of the tangent, which is also called gradient of this tangent is negative here, right? Since if I sketch a tangent line, you see it goes down, right? And right in the center where we have a turning point, it is 0, right? So let me write m equals to 0 here, and m is equal to negative, means m is less than 0, right? But on the right hand side, if I draw a tangent to the curve, we see it is a rising line, and so the gradient is greater than 0. It is positive. So in a way, we see that the gradient is always increasing from negative to positive. It will be something like this. Do you see that? So a very important conclusion here is that the gradient always increases. It was in the beginning on the left hand side negative, then at the turning point it is 0 and then becomes positive. Another key feature which you also note here is that the gradient is 0 at turning point, right? Perfect. So these are key features which we notice when we have concave up in the graph. The tangent is always below the graph. It is always increasing as you move from left to right, and at turning points the gradient is 0, slope is 0. Perfect. Now let's analyze the parabola which opens down, as I have taken here. So now we'll take up a parabola which opens down. So the characteristics which you see here is like what? Well, once again, let me sketch the tangents. As you can see, tangents are above the graph, right? So in this case, they are above the graph, right? Let me write tangents The graph itself is called concave down, right? Opens down, correct? So the shape is concave down. What is happening to rate of change as we move from left to right? Well, if I draw a tangent on this side, it has a positive slope, right? Then it becomes 0, and then it becomes negative. So it changes from a high positive to low positive, 0 to low negative, and very high negative, right? So we do notice that the gradient or slope or rate of change in from positive to negative decreases all the way, right? Decreases all the way. So in earlier case, we saw when it was concave up, it was increasing. Now when it is concave down, the gradient or the tangent is always decreasing. And of course, at the turning point, we do notice that the tangent is 0, right? 0 slope. So gradient is 0 at turning point. Perfect. So at this point, we see that the gradient is 0. So can I conclude that always when the tangent is below the graph, in that case it will be concave up. If tangent is above the graph, then the graph will be concave down, and at the turning point, the tangent will be 0. Well, these things are true. But remember one thing, if the tangent is 0, slope of the tangent is 0, will that be a turning point? Well, if I put it the other way, it may not be true. So let's try to see the third graph which I have, and it's with a purpose. So here we have a cubic function, right? Now what you notice here is that one part of this left of origin, you can see that it is concave down, right? So this portion, it is concave down, right? And on the right hand side, it is concave up, right? So this portion is concave up. So it's a combination of both, right? Concave down and concave up. Well, our properties which we learned is if I sketch a tangent anywhere on the concave down portion, then tangent is above, right? Correct? And on the concave up, it is below. So those things still work. But see, we do have right in the center, if I draw a tangent here, what happens? It goes through the curve. So important thing here is that gradient of tangent is 0. But this is not a turning point, right? In this case, not a turning point. The tangent actually crosses through the curve. It crosses through the curve. This is called the saddle point. And also point of inflection. It is very important to notice that here the concavity changes. From concave down, it is becoming concave up in this case, right? So wherever the tangent gradient is 0 and the concavity changes, that is called a saddle point or a point of inflection. You get the idea. So from here you learn many things, right? So let's summarize the results once again with the help of these three graphs. So concavity, we see that is concave up, right? So that means 0 at a turning point. So this is the turning point. And from negative value, it becomes positive. I should write 0 here, right? And then positive. So we see that the gradient here always increases. So that is the gradient, right? When we have the case that it is concave down, in that case, we do notice that gradient is 0 at the turning point, but the slope changes from positive to 0 to negative. And therefore, the graph in this particular case for the gradient will be going downwards, right? Now here it is a mixture of both. We see that this positive here it is 0 and then again positive. So when the concavity changes, right, we have a point of inflection right there where the tangent gradient is 0. The gradient crosses through the curve, right? It is not that the curve is above or below it, right? It actually crosses through it. The concavity changes. You can see that. Perfect. And what you notice here is all throughout, in this particular case, we have a positive gradient, or it is non-negative. Do you notice that? So that's very typical of a cubic function. Perfect. So I hope with this, the concept, whether the tangent is below the graph, above the graph, what type of graph it is it concave up, concave down, is it a turning point, or is it a point where the concavity changes? I think these concepts are very clear to you from this particular explanation. Well, in case you want to learn from me, you can always send an email on the address given. You can also check our website for the latest updates. Thanks for your time and all the best.